So without further ado, would love to welcome Karl onto the stage. So Karl, whenever you're ready, feel free to unmute and share your screen. Karl is listed on this chat as Karl with many OP with many exclamation points. So you know he's excited. There you go. Welcome to the chat, Karl.
You already know. How could I not be? Oh my goodness. Let me make sure that I'm okay. I got all the things.
You're all set?
I'm all set. We did
Awesome.
it, Reddit.
There you go. Everything looks
all
great.
right.
Well, I'll get out of the way and excited to hear more about the OP stack.
Okie dokie. So welcome everybody. Going to talk about the OP stack, Bedrock, and the rise of the super chain. And we actually got a solid amount of time. I didn't realize we had so much time, but I got to fill up all the time. So without further ado, I'm Karl. Of course, I work at OP Labs, doing this optimism stuff. And so now, whenever I give this, or whenever I talk about these things, right, these words pop up on the screen, there's one word that everyone sees. They don't see the rest of the words. They see super chain. That is what they see realistically. So I'm not going to start off by talking about the super chain. I'm not going to talk about how it is, you know, all these chains kind of combined into one super duper fantastic thing. I'm not going to talk about that to begin with. Instead, what I'm going to talk about is the problem. Ethereum congestion back in 2016, 2015. This has been a problem for way too long. Oh my God. It's been a long many years. But we've had too much demand for Ethereum. Ethereum is too good. And so what happened? How did we solve Ethereum congestion, realistically speaking? Well, we copy and pasted it into more chains, all these various chains generated by Dolly 2. That is what we did. That is what we did. And then what did we do? Well, we connected these chains with largely insecure bridges, these largely insecure chains, realistically speaking, and we kind of hacked some together to address this horrible problem of congestion. And in some sense, optimism is kind of one of these things, right? It is a layer 2, but from a user experience perspective, it still has a bridge. It still, you know, feels a little bit distinct. But it does have the nice quality of being rooted in Ethereum and in sharing some of that security. And so, right, this is kind of the state of affairs in some sense. And, you know, if I'm a user, this like cute little gerbil also generated most of these photos are generated actually. Then you're, you know, going from one chain to another, trying to like deposit, withdraw. It's just kind of chaos, to be honest with you. And you can kind of visualize this as a crazy like market, right? It's like a marketplace and you're going from these different sellers and, you know, maybe you go to this person, you're transacting on this chain using this vendor and behind you, there's a bridge that just exploded and another one that just exploded. And then you went to this other chain and now, you know, it's actually a rug pull. Like it is true and utter chaos right now. This is not good. This is not a user experience worth bragging about, right? This is just honestly very sad. But, you know, it's better than no one being able to transact, which is the alternative because Ethereum was just way too congested. But we can do better. We can do better. And what if I told you that there was a solution to this problem? There was a solution where instead of going from one place to another, everything is all in one place. And you don't have to transact with all these different, you know, vendors. You can instead transact with one trusted seller. And you've got seamless atomic checkout in this market. Well, it's the supermarket. Dun, 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 dun. Whoa. Oh my gosh. Okay. This is a joke, right? We're not here for supermarket technology. But it's just, you know, supermarket, super chain. Anyway, really though, I can't help myself. Our chain should have these properties, right? We demand these properties that, everything in one place, a single trusted seller, so you're not getting hacked all the time, right? We shouldn't have to bridge from one chain to another. We shouldn't have to get hacked. I mean, my goodness, that's a low bar. And also transaction fees should be cheap and sometimes pretty much free. Like that is legitimately, there is no technical blocker. And so there is no reason why we should not achieve this. Don't fear though, don't fear. The OP stack is here. All right, we finally got to the actual meat of the talk to an extent. Well, state of affairs, kind of crazy, absolute madness, but we can fix this. How do we fix this? Well, we can build standardized open source libraries that provide shared security so things are actually secured, rooted in Ethereum. There are fallback mechanisms. There are things that prevent terrible hacks. Also, just the fact that it's standardized makes it way more secure because now there are way more eyes on it. It's not just a one-off solution because that's how you get hacks. Additionally, composable, right? We need these systems to all work together. You can swap out one module. They're compatible with one another. And additionally, finally, coordinated sequencing. I won't talk about how incredibly important that is, but it is actually incredibly important for creating an experience. Now, what is this experience that the user, at the end of the day, right? All of this technology is in service of building something that we can all use, right? I want to use a better product than we have today. And so what is the user experience of this system? Well, you actually, with the compatibility that this, the shared technology enables, we can actually create a virtualized single superchain, right? We can actually interact with the system in a way where you're not having a bunch of user-facing bridging. All that kind of stuff can be handled in the background, right? We can have robust modules that ensure security. And additionally, it should be hella scalable, with horizontally scalable. Some call it, quote, infinitely scalable, but I feel like that's just like a savage marketing term. Horizontally scalable, so we can have near free transactions that essentially cost the amount of money that it costs to run that transaction on a computer. So it's like renting from AWS as opposed to paying surge pricing on Uber. So we can realize this super chain. We can realize it with open source technology, shared standards, and working together. And we can make that happy experience for our happy gerbil. Now, if we want to talk about how exactly the kind of like combination, the virtualization of the superchain works, you can kind of take a look at Endgame that has a bit of a hint at it. And then there's even more talks that we can go into, but I won't do it right now because we don't have enough time, or at least so I thought. But you can ask questions at the end of the presentation. So now we are past the intro. Maybe I needed all the time that we have. Let's talk about the core of the OP stack. So this is not necessarily everything, but this is the kind of bread and butter. Okay, what is the OP stack? Again, standardized open source modules for layer 2 chains. We are using it for, of course, Optimism mainnet, but it is open source, therefore anyone can mess around. Now, there are 3 key layers to this, right? Any stack has some layers: the consensus layer, the execution layer, and the settlement layer. Consensus, that's how the chain gets constructed. The execution, that's the virtual machine that is actually being, executed over this chain of inputs. And finally, the settlement layer, that's how withdrawals occur. So if you look into layer 1, if you look closely with a magnifying glass, you will see that layer 1 is actually made up of its own consensus layer and execution layer. So this is a recent change that we've modularized layer 1 in the very same way that we're trying to modularize the layer 2 technology. And the way that that works is that we have Prism, these consensus layer clients, not just Prism. Don't just use Prism, y'all. We need diversity. Additionally, we have execution layer clients like Geth. And we have that same structure playing out in layer 2 as well. Now, let's get into the nitty-gritty of the consensus layer, execution layer, and settlement layer. what are these different things? So first, for the consensus layer, we have two key modules, two options that we can choose from. We can either choose rollup, which basically means that all the transaction data is fully available on chain, or Plasma. Now, Plasma got a bad rap back in the day. It was just too early. And now there's a million different terms for Plasma, like Validium, all of these things, the various things. Basically, at the end of the day, we should just call them data availability challenges. We have a consensus layer client that has off-chain data with data availability challenges on chain. So those are our two kind of like broad categories of consensus layer type deals. Additionally, we've got execution layer. So that is the EVM, the classic one, right? We've also got extra fancy ones like this weird one in the middle that I'm kind of just like hinting at, but not saying because I don't know if I should talk about it yet. But anyway, we've got other execution clients that are special purpose, maybe for some games, maybe not, whatever. And then finally, we have the settlement layer. This is how things actually get withdrawn from the system. This is how you kind of prove the withdrawal. Now, notably, I have here multi-sig, fault, and ZK proof. I am writing this as though the settlement layer is, if you have a fault proof or a ZK proof that is, kind of working, but you still have a fallback to a multi-sig, then because of lowest, the weakest link security, at the end of the day, you're still multi-sig. And so that's why multi-sig is here. Obviously, no one wants multi-sig to persist into the future, but the reality of layer 2 right now is that things are being secured, withdrawals are being secured by the multi-sigs, which is, it's better than it being secured by an insecure proof system. So let's be thankful. Anyway, consensus layer, execution layer, and settlement layer, right? You can choose each one of these. And, if you choose this configuration, then you'll end up with an EVM equivalent optimistic rollup, right? This is the perfect flagship for an L2, but it's not necessarily the only configuration you might ever want. And it does have different security trade-offs or withdrawal trade-offs, right? All of these things are trade-offs. Now, additionally, right, eventually you'd want to plug in potentially a ZK rollup, a ZK proof system, a ZK settlement layer. And so what that means is that we can have an EVM equivalent ZK rollup. And additionally, because it is modular, we can swap it in and swap it out. So the same chain that was running a fault proof can, without changing anything about a developer experience, without changing anything about, the nodes that people are running, you can actually swap in a different proof system for withdrawals. And so that means that we can get these like seamless upgrades and write compatible software. Actually, in fact, the key to scaling up the production of software is defining really good abstraction layers. And so, this is actually more important than you might imagine, because it allows people to work on different things in silos and still be compatible once they have done the incredible amount of work. And ZKPs are a great example of something that's going to take a lot of work to make extremely inexpensive. And let's continue. So we've got the consensus layer, right? We can do things like layer 3 by layering in Plasma with the EVM and fault proofs, right? All of these things are options, and even swap out the execution layer. All of these, configurations are valid, but the key is that we should make sure that the way that they communicate, the way that these layers communicate with one another is standardized so that we can all benefit from each other's innovations and build out the blockchain stack, candidly, in an open source and permissionless way. So that is the core of the OPizzle stack izzle. So the Bedrock release. We are finally at that section. Okay, what is Bedrock, right? Bedrock is a major step forward across two primary dimensions. So first off, obviously, it is the next upgrade to Optimism mainnet. That is, we are upgrading our mainnet. If you deposit into Optimism, then that thing is going to be using Bedrock very, very soon. And that's going to make it the most, literally like the most secure, the most scalable rollup that is out there. Let's go. So Bedrock is actually legitimately extremely, extremely dope. The second thing is that it is a foundational it supplies the foundational OP stack modules, right? We built it out in this modular way already. And in fact, in the later talks, with Josh, with et cetera, we'll go into the details of like how these things actually fit together and what components we built. So, right, we have a configuration of the OP stack, and we have all of these different packages which it is using, right? We have this OP node, which is the consensus layer kind of equivalent. We have OP Geth. We even have OP Aragon, right? This is literally 2 Ethereum clients that are compatible. Additionally, we've got all of these other, Batcher Proposer contracts. We have Canon for fault proofs. All of these things are built in this modular way. And so here, I'll go over into like more specific details of like where the major steps forward in modularity are. So first off, modular execution with the engine API. So first, I started this talk by saying how the consensus layer and the execution layer are actually being, built out and were created for layer 1 development. Well, what did we do? Well, we swapped out the consensus layer and replaced it with the OP node. So now we're coming to consensus by using L1 consensus. That's literally like the definition of layer 2. Additionally, we have the execution layer. So we have Geth. But we can also swap in things like Aragon, and it takes very little code to modify these execution layer clients to support layer 2s. And that is critical, right? Code reuse is a key factor of security, and these systems need to be more secure than any other system you've used. Let me tell you, it is. These security requirements are insane. And so this also enables us to have a multi-client ecosystem. We would never have made the merge upgrade. We would never have done the merge upgrade without multiple clients, because multiple clients catch divergences between them, making the entire system more secure. That's why the merge went through without any critical bug reports, right? That is literally the technology, that the security technology they used was a multi-client ecosystem. And so we need that very same thing for layer 2. And that is absolutely critical if we want to enable fault proofs, for instance. And I'll talk about that a little bit more later. So yes, additionally, we can even have more fun, and maybe it's not going to have a multi-client ecosystem, but we can input this like weird mystery VM, and boom, now we've got even more execution engines that we can use. So that is the first step, right? It's the engine API. The second thing is modular derivation. So first, execution. The second one is derivation, or the consensus layer. So in back in the good old days, a year and something ago, when we were writing our rollups, we thought that we needed a bunch of smart contracts on layer 1 to actually derive the rollup. So essentially, you take in L1, this function, right, is like the rollup function. It produces the layer 2 blocks. And what we were doing is we were saying, okay, you need layer 1 and you need some smart contracts on layer 1 to do some like management for you and whatever. But this meant that the system was actually really brittle. It was really hard to upgrade because you always needed to maintain these layer 1 contracts. But now what we're doing is we're consuming raw layer 1 blocks, raw layer 1 block data to produce the layer 2 chain. So what does that actually mean? It means that we can swap in, because it's just like a raw stream of data, we can swap in new data sources like EIP 4844 or even Plasma, right? Things like off-chain sources of data. So this allows us to, both scale up, be ready for when we're improving layer 1, because we're pushing forward EIP 4844, which is a major improvement to layer 1, but we're also able to support things like layer 3. And finally, modular proofs with Canon, right? Canon it generates the execution trace over the client, and it allows us to prove that execution trace, but we can prove an execution trace with either fault proofs or ZK proofs, right? These two things totally work. The ZK proofs might be too expensive right now, but that's something that we can work on over time. And importantly, Bedrock again supports multiple clients, and multiple clients is incredibly important to support production high security chains, and specifically to support fault proofs and ZK proofs without big bad upgrade keys, right? We need our upgrade keys to be, you know, upgrade, and then you wait like 2 months because you can actually withdraw. And we need them to make sure that the mechanism that allows people to withdraw from layer 2 in case there's a malicious upgrade, we need to make sure that that mechanism will never break. And the only way to make sure that mechanism will never break is with multi-client support. So there we go. You know, more information on that in our pragmatic path to decentralization, because we need to get rid of those upgrade keys. We need to not be multi-sig rollups. Anyway, great. This, you know, this evolution, right? The state of affairs, this madness with these bridges going crazy and these different chains and this terrible user experience. We're already making progress there, right? Bedrock release is fast approaching. We're about to take a massive step forward in the OP stack. Additionally, we already have multiple OP-based chains. So it's like not even, this is not even like a, oh, we need more OP chains. Like literally we accidentally had people deploy OP chains just because we were writing our software out in the open. And additionally, we've got teams experimenting with Bedrock, pushing the boundaries of what was possible on chain, right? We're gonna break through even the scale, like the scalability that we have today is not even close to what we're going to have tomorrow. It's like you don't think about the resource constraints on AWS unless you're a massive, crazy, team. But if you don't really think about the scalability constraints on AWS as an average individual, you should not be thinking about the scalability constraints as, you're transacting or deploying dApps to a blockchain. This is just the beginning, right? We are about to take over with the zombie horde of gerbils generated by artificial intelligence. We will take over the game. And soon we will realize the final evolution of blockchain. Walmart, no, I'm just kidding. We will finally realize the super chain. Thanks to the OP stack, because we're working together to solve the problems in a secure and scalable way. Hallelujah. We're going to provide that good user experience to us because we're the users too, And the rise of the superchain. That's it. And by the way, this is also a superchain image, but including a gerbil. And I just love the way that these AIs, or like Dolly specifically, cannot spell. It's so good. Anyway, thanks everybody. I guess we don't have that much time for questions, but happy to answer them. Oh, Pizzle, stack Izzle. Let's go. All right, that's it. I mean, I don't know. I'm now in my room. I still feel like I'm in my room. Is there a place I should be looking for like questions? Do we have like a couple, I don't know. I don't even know. I don't know where I am. Well, I feel so alone. Wait, am I? Oh, it's because I turned off my mic because I can't hear, maybe? Hello. Okay, fine. I'll just talk then.
Hey, Carl. Sorry.
Oh, great.
No, I think. Hi, it's me. No, I think I don't see any questions. I think we're good.
How did you find such a cute dog photo? Well,
yeah,
type
that
in
would be my question.
Dog on Google. All right, let's move to Josh.
Yes. Okay, awesome. Carl, thank you so much. I love your presentations. You're so enthusiastic.
Thank you.
You're awesome.